Okay, we are going to measure total harmonic distortion using this Amprobe ACD-41PQ meter that measures total harmonic distortion in both the current and voltage waveform. It also performs other power quality measurements, but we're studying harmonics right now, so we're going to use it for it. I'm going to compare the values that I read with this guy right here, which is a 125B industrial scope meter with a harmonics measurement function. So the 125B has a current probe attachment connected to it, which will convert the current signal to a voltage signal and measure it in the scope. So let's start out with our current measurements on the main leg of this panel. And let's have a look at those right now. Okay, so sorry about the camera moving around, my crew didn't show up today. So you'll notice that we have about 17.2 amps of current flow and about 14% distortion in that current. Okay, let's have a look at this meter. 17.6 amps RMS of current flow and 14.9 THD, total harmonic distortion in that signal. Okay, now I'm going to change something here. What I just did is I changed the reading to read %F or % fundamental harmonics, so I can do a direct comparison to the Amprobe meter. So what we'll do now is we're going to try to find the load that's causing some of the harmonics, and I think I know which one it is. I think it's the VFD that's running in the background. So we'll take this meter and we'll clamp it on to that circuit. Now, what you're going to notice though, and this is important when you're working with this meter, is you can see that we've got about 0.73 amps of current flow, but it doesn't have a reading for distortion. Now, there's a reason for that. That is what we call a split screen, where we can read the current and distortion, but it will only read up to 100% distortion. This meter will read up to almost 1000% distortion. I just hit the THD button. So now the primary display is only total harmonic distortion, and it's reading 206%. That's a lot of distortion. Now, it's only drawn about 0.73 amps. So the overall current that the panel is supplying through the mains, this is a very small portion of that, so the total demand distortion is very low. There's basically no voltage distortion. Okay, when your voltage distortion hits around 5%, then you know you have a problem. So what I'll do now is I'll take this clamp meter from the Fluke industrial scope meter. I'll put it on the same wire. I have to get my polarity right here. And we're going to look at the readings on the Fluke industrial scope meter. And we have 0.74 amps, we'll say, and around 212% THD, total harmonic distortion. Now, the difference between the Amprobe meter and this very expensive meter is this very expensive meter will show you the subcomponents of all the distortion, and I will explain that in another video. I just wanted to compare the two. This meter reads up to the 51st harmonic. It doesn't display the percentage of each harmonic, but it will include those components in the overall distorted value that it reads. So it's a really good, simple meter for troubleshooting harmonics, especially for isolating. If you want to find out if you have a problem in your system, it's a great meter for that. Always wear your gloves. See how dirty my gloves are? It's because I always wear them. Wear your PPE when you're working with these meters. Okay, so if you want to get into troubleshooting harmonics, you don't want to go too crazy, get yourself a power quality handheld clamp meter and start with that. Read the manual. There's a lot that you can do with that meter. Okay guys, catch you in the next video.